Hi everyone, this is Andrew McHarg, and this video is designed to familiarise you with the correlation coefficient, which we also call the R-value. Thanks to John Short for the examples from his General Maths 3 compendium. In this video we're learning to obtain the correlation coefficient using the ClassPad calculator and interpret the correlation coefficient using the table provided on the information sheet. Now the correlation coefficient indicates the strength of a relationship between two variables. Sometimes it's a very strong relationship, but sometimes there's no relationship at all, or a very weak one. The R value helps us to decide on that strength. We obtain the R value using the statistics section on the calculator, this one here. So here we've got two scatter plots. So on the left we've got strong correlation. So these data points line up very straight and have a very strong relationship in that positive direction, very obvious relationship. Now, if we were to add a few extra points here, not that big, so I'll just add a few points around this. Now, we see here, if I start doing that, adding some extra data points, now the relationship's still quite strong once I add those points, but not as strong as when the data points are all lined up perfectly. So the further the data points lie from the line of best fit, the weaker the relationship. Having said that, this is still a strong relationship once I've added those data points, but not as strong as before I added them and the data points all lined up perfectly. Over on the right here, we've got no correlation. These points are randomly scattered. There's no pattern in either direction, so they don't follow a pattern up that way. They don't follow a line down that way. No correlation for this situation, so we'd say no relationship between the variables. So we use this table here to decide on the strength of a relationship. On the left here are values from -1 up to +1 and intervals showing what type of correlation exists along this continuum. So from 0.75 to 1, we have strong positive correlation, a strong relationship between the variables. Now at the other end of the scale, -0.75 to 1, still a strong relationship, but in the negative direction. And in the middle of the table, no correlation around the value 0. Okay, so having said that, let's see if you can decide on which plot best matches, or which R value best matches each of these plots. There are 4 R values, which means that one of them doesn't match at all. So using the table back here, decide which R value matches each of these plots. You can pause now and have a go at that. Okay, so let's see this first one. Now, see a definite positive relationship there, and the data points lie quite close to the line. So I'd be thinking that this is a strong correlation in the positive direction, so strong positive correlation. We look back at the table, strong positive correlation exists or has the values, just get this line up, that's the one I want, from 0.75 to 1. So which of these values lies between 0.75 and 1? Well, it's this value here, 0.95. Okay, in the next plot, well, still a positive relationship. The data points follow a line up that way, but not as closely in the first plot. So probably a moderate positive correlation. So that is for values between 0.5 and 0.75. So I'd be picking this one here, R equals 0.6. Okay, over to the final one here. Now this is a negative relationship going down this way. Is it moderately a moderate correlation or strong correlation? Well, I think those data points lie quite close to the line. I'd be thinking strong negative, which is going to be this value here. Okay, so this R value indicates negative correlation, moderate negative, it would fit into, which would fit a plot like this one here. So we see the data points going in the negative direction, but not following a line all that closely, but still showing some type of relationship there, or some strength to the relationship. Okay, now we're going to have a go at obtaining the R value using the class pad, and we're going to interpret that R value. So when we interpret the R value, we use these sentences here, okay, but instead of X and Y, I'll use a smaller line there. Instead of X and Y, we need to put the variables in question here. So the X and the Y variable, you guys need to decide on what those are. Okay, so first thing, go into the stat mode of your calculator and enter that data, and then I'll show you what to do. Okay, so here's the data entered. We need to obtain a linear regression. So we go to Calc, Regression, and Linear Regression. Okay, and at this stage we can just say okay. Later on we're going to change these things a bit when we learn some other stuff, but right now this is fine. Okay to this, and here's our R value here, 0.9454. Okay, 0.9454. All right, I'll just get a copy of this. All right, so where does that fit into the table? I'll just put that over there. You guys can write that down, 0.9454, that's our R value. I've got to do this before the battery on my computer runs out, so look out. Right, we're looking here at what type of correlation? Strong positive correlation. Okay, you can pause at this stage, go back and put the variables in for X and Y rather than, or we've got the two variables in question, daily temperature and number of soft drinks, number of cans sold. Okay, see if you can get them the right way round. Okay, you can write that and pause the video and write that down, and then down here I'll reveal the answer. See it there? Okay, have a go at it. Righto. So here is the sentence that you should or could have written. There is a strong positive correlation between the variables. The greater the daily temperature, the greater the number of cans sold. So important that we put the independent variable first and the dependent variable second. That's very important that you get them the right way around. Daily temperature is the independent variable, number of cans sold, the dependent variable. Okay, everyone, I hope that was helpful. Thanks for watching. I'm going to save this video before the battery on my computer runs out.